Hi folks, I'm Callan Bentley. I teach here at Piedmont, Virginia Community College. And today I want to take the opportunity of this video to teach you how to make a joint. Yes, that's right. We're going to make joints today. We had a little activity here in our lab with our PVCC Geology Club, and we made joints which are fractures in the rock. And the way we made these fractures is kind of cool, and the resulting fractures are very cool. So let's take a look at what we did. But first, a little background. Fractures are really common features to find in rocks. Rocks break, especially under Earth's surface pressures and temperatures. And they're more likely to break, of course, if we apply stress to them very quickly. There are different kinds of fractures. Fractures along which there's motion we call faults. Fractures that have dilated, opened up enough to admit space for igneous material, for magma to flow in. Those could be dikes or sills, or maybe it's just a solution of water that's got some stuff dissolved in it, then that crystallizes out and makes a vein. All those things, when you look at them in cross-section, and we're very comfortable looking at them in cross-section in geological diagrams, they look like lines. But remember, that line is simply the trace, the cross-sectional trace of a more planar structure. And you think, okay, so it's a plane. Geometrically, it's like a sheet of paper more than it is like a pencil. But even that analogy breaks down because it's not shaped like a piece of paper in 3 dimensions. So the actual shape of a fracture is often a shape that we call an ellipse, all right? And an ellipse is kind of like a circle that's been drawn out a little bit. It's like an oval. And typically these things are about 2 or 3 times as long as they are wide, all right? And they often have, especially in really fine-grained rocks, we see these little details of the surface anatomy of this fracture face, or this joint face. A joint is simply the name for a fracture that doesn't show any differential motion. So one thing we might see is we might see a series of what are called concentric ribs that are little sort of arrest lines where the fracture, as it's growing from its point of origin, it sort of stops there for a minute and then keeps propagating. So they're little sort of pause points. Running perpendicular to those are these features that we often call plumose structure. And plumose structure has a pattern that looks something like this. All right, so you get these sort of branching, feathery looking features. And you can really read these as a story of fracture growth, of starting in one place and going towards another place. And oftentimes, as the joint opens up, so in the third direction, the Z direction, if you will, from the X to the Y to the Z being perpendicular to the plane of the whiteboard, that'll allow a little bit of stretching, especially here close to the point of origin, and you'll end up getting these little things that develop along the sides, which are actually like little miniature joints that kind of flare off of the main one. And these also may show things like their own little plumose structure, or you can even potentially see little concentric ribs on those as well. So these little things along the edge, they look like the little ruffled bits on the outside of a feather, and they're called hackles, all right? So this is the hackle fringe. These are these plumose lines, and then these guys here are these concentric ribs. So all these various features are features that we can see if we go and look at joints that are sufficiently fine-grained as to preserve these features. And we're actually going to go ahead today and try and make some joints with an experiment where we're going to make a fake rock out of gelatin, so it's transparent and we can see through it. And then we're going to cause that gelatin rock to break by jacking up the pore fluid pressure. And the specific fluid that we're going to inject into the gelatin rock is Plaster of Paris. So we're going to mix up some Plaster of Paris. It's going to be liquid and goopy. Pull it up into a syringe and then inject it into this gelatin rock. And it's going to cause the gelatin rock to break, and it's going to make a joint that looks a lot like this. And we're specifically going to get this joint to form in a certain orientation by exerting some stress on the gelatin rock. So we're going to take a carpenter's clamp, we're going to squeeze it a little bit from the sides, and then we're going to raise the pore fluid pressure, and that's going to cause this joint to form. It's a really neat experiment, so I hope you enjoy watching this. All right, here we go. And do you guys see that? Wow. I'll release the stress field now, and we'll turn it so you can see the beautiful shape of the joint. So notice that it formed perpendicular to the stress field, and then it's about at a 30-degree angle to the top-bottom axis, right? Note the beautiful plumose structure and the flaring out of the little hackles along the edges. So this is a look at the joint that I produced, and you can see that it is very thin, not completely thin, not a perfect, planar object, but it has a certain shape to it, right? And that shape is that it curves up a bit at the tip, it sort of flares down a bit below my thumb, and you can see that the main joint face breaks up into these little hackles on the edges, and those are really well pronounced, and the hackles are kind of lined up with the plumose lines that you can see sort of originating out from the point of origin, which is near my thumb. So that's where the plaster injection initially took place. So that's the shape of fractures. And when you see a little line in the rock, a vein or a similar feature, you are actually looking at a cross-section of a structure like this. Sometimes you're lucky enough to see just a cross-section of the little hackles, and that looks like a series of little tiny veins that are short in their duration. We call those an N-echelon arrangement. But it's a beautiful structure that forms in nature, and I hope you get a chance to see some in the field.